So for tutorial question number 4 for the bending equation, again, draw it out to start off with. I would always recommend you do it. There's your I-beam. 120 millimeters by 240 millimeters deep. The depth is the key, deep. So 240 millimeters is this vertical dimension here, with the neutral axis halfway along the I-beam like that in green. It's the web. So the web is the central bit here. This is the web. And the flanges, top and bottom, so these are the flanges here, both have a thickness of 25 millimeters. Determine the second moment of area of the section. If the bending stress is limited to 100 meganewtons per square meter, determine the maximum bending moment. So you're given the value for the stress, and you want to find the maximum bending moment m. So obviously the part of the bending equation we're not going to be using is this one that involves Young's modulus in the radius of curvature. So we've got to find I and then use I in this formula to calculate the maximum bending moment m. Looking at the way this thing is written round, look at the formula for the second moment of area for an I-beam. You've got to calculate what little b and little d are. And you can see from the diagram, hopefully, how to do that. Okay? So see if you can carry on from there and get out the solution. So little b will be 120 minus 25 over 2. Little d will be 240 minus 50 from the dimensions of the thing. So now we can plug those into the formulae to get the second moment of area. And once we've got that, we should be able to find out what capital M, the moment is. And we find that the stress, sorry, the moment, maximum moment on this turns out to be 69.95 kilonewtons meters. So that's the answer that you should get. So you might want to pause here, and then I'll carry on and go through the solution in a second when you've had a go at it. So I equals that, putting in the values, making sure that capital B and capital D and little b and little d are all in meters. So for consistent units, I don't know, we get that I equals 83.94 times 10 to the minus 6 meters to the power 4, which is what we measure the second moment of area in. So finally, to get the moment, it's sigma over y times I, which is the value we just calculated, and y, remember, is the distance from the neutral axis to the top of the beam. So y is this distance here, which is going to be 0.12 meters. And then you should get the value for the moment, 69.95.